Hello, is my mic on? How's the volume? Good? Too loud, too soft? Good? All right. Let's get started. So today we have a 2-hour lecture. I'm going to be lecturing on the first half on tables and the second half on rows. We'll try to keep it light and easy because it's a Friday and we have a 2-hour lecture. So let's get started. First, announcements. So homework 2 was released late last night, and it will be due Tuesday at midnight. Do you think someone could close the doors in the back? Thanks. I also want to mention that because of the issues we were having with Jupyter Hub, and because we've had some late joiners and late people who joined the class, we've decided to push back the deadlines for homework 1, lab 1, and lab 2 to Tuesday of next week. So in theory, you could wait until Monday and do all 4 on the same day, but you'd have a bad time. Any questions about that? Yes.
So, are you familiar with the OK.data8, etc. website that we use to check if our homework's been submitted?
okpi.org, you mean?
That's the one. So on there, I had done all of the checkpoints and saves in the labs and the homeworks. When I checked on that last night, it said that nothing had been submitted.
Yeah. So so your name is Jared. So Jared mentions that in OKPy, when he worked on his stuff and he ran OK.submit, he didn't get like some of the backups are on OKPy, but none of it doesn't say he submitted the homework. We don't know exactly why that's happening, but we're looking into it. But fret not. We will automatically take your latest backup to grade when we grade our stuff. So even if you forget to go back in and mark something as submitted, we'll take your latest backup automatically and grade that. So as long as you have a backup there, we'll have something to grade. If you want to select something other than your latest backup to grade, you can go into okpi.org and click Convert to Submission. You can go to your backup, click Convert to Submission, and that'll tell us to grade that particular backup instead of your latest one. Yeah, did you have another question?
Yeah, would you prefer that we convert them to submissions, or can we just submit in our last conversion or the last save?
Would I prefer that you guys submit, like have a submission for the homework? To me, it doesn't matter because I'm not doing the grading. But I don't think it matters for us either way because later on when we get the issue fixed, it'll automatically be converted to a submission. We're not super sure why it's not being converted now, but we're looking into it. We'll try to have it fixed by next week. Good question. All right. So today's Friday. We'll try to not do all serious business today. So here's the data of the day. It's a pie chart showing the letters in data. That's it. All right. So here's a puzzle of the day. So among the 72 responses to the Data 8 welcome survey, how many people have your birthday? How many days have at least 2 people with that birthday? How many days do you think have 4 people with that birthday? And what's the largest number of people that all have the same birthday? So you don't have to answer this now, but just think about it, and we'll get back to it at the end of our 1-hour time here. Cool. So today we're going to be talking about tables. Most data in the world is arranged in a tabular format or is worked most easily with in a table format. So once we learn about that, we'll be set to go for most of the rest of this class in terms of data manipulation and just working with data. There's a standard library used out there in the data science world. It's called Pandas, short for Python Data Analysis Library. This library can do a lot of stuff, but also is very hard to learn, unfortunately. Because of that, for this class, we've developed our own library called Tables, that we've called Tables. And when you go on beyond this class, it's very easy to convert between our table into a Pandas table or Pandas data frame, as you may hear it called. So what we're going to do in this class is use our library called Tables and teach you all the concepts so you guys know, OK, I need to do this to a table in order to get out the information that I want. And when you guys go on beyond this class, you should find it relatively easy to translate your syntax over to the Pandas library where it'll be harder to work with the syntax, but it's just considered the standard today. So in this class, we'll use tables because it's easier to learn and a lot easier to work with in general. Cool. So a table is a sequence of labeled columns. In the abstract sense, you can think of it as like a rectangular grid of data. Each column is labeled with a string, and each column's data is an array. There's an additional constraint that each array needs to be the same length. So you get something that looks like this, where the name here is a label as a string, and the name column contains strings, California and Nevada. On the other hand, this column right here is called area, and the items in this column are numbers, are integers. Okay, so just to recap, label, column, and what we do typically in tables, we consider each row a single entity, a single data point, oftentimes. Okay, so for example, this row all refers to Nevada. The name of the state in Nevada is Nevada. The two-letter abbreviation for Nevada is NV, and the area of Nevada is 110 square meters. Okay, so let me show you what I mean with the demo. So as usual, I'm going to be working on data8.hos and OK, new notebook. So what I'm going to do before I start is import. You won't often have to do this. And what I'm going to do here is set some options so that it prints more nicely just for this lecture. But you won't have to do this either. This is just for today for this lecture. Okay. Before I can use a table library, I need to import it from the data science package. And when you import the data science package, you get a special method called capital T table. And when I call that method, when I call that function, I get back an empty table. So not very interesting there. But once I have an empty table, I can add data. I can add columns to it. So I can take my empty table and add a column. And what I do, the way that this works is the first argument here is a name of a column. The second argument here is the data in that column. So I can make an array. And now my table has one column called petals. And here's 8, 34, and 5. Okay. If I want to add multiple columns to the table, it's not so hard to do that. All I need to do is pass in more arguments into the with columns method. So here I'm going to pass in a second argument called name. And I'm going to name it lotus, sunflower, and rose. Okay. Any questions about that? All right. So let me call this table the flowers table. If I don't assign, so again, if I create this table but don't assign it to a variable, I won't be able to use that table in the future. Python will create it, will show it to me, and then it'll throw the table away. If I want to save that table, I need to put it into a variable, assign it into a variable. And now the flowers table refers to the table with the petals and the name. I can add another column to the flowers table by calling with columns again. Sorry. And let's say I want to add the color column to the table. Pink, yellow, red. And now flowers has, so now this is a table with 3 columns. Now here's a catch. Okay, so if I look at the flowers table now, the flowers table still has 2 columns. Why did that happen? Well, what happens when you call .with columns and when you call most other methods on a table is that it creates a new table. It doesn't actually change the original. So the flowers table is still the table with 2 columns, and the with columns method creates a new table with 3 columns. Just like how if I had a variable called x, and I run x plus 2 is 4, but x is still 2. Okay? So similarly, the flowers table is unchanged, but the with columns creates a new table. So very important in case you're working through some problems and you're like, wait, my table hasn't kept any of my updates to it. It's because you have to assign this result into the flowers table again. Okay, so what I'm going to do here is I'm going to say flowers equals flowers.width columns. And now I'm changing the flowers variable to point to that 3-column table. So if I run that and then show you flowers, now the table has 3 columns. Okay, so this brings me to an important point, which is the concept of changing variables. So again, an expression here does not change the variable. So x right here is, let's say x is 3, x plus 2 is 5, but x is still 3. Okay. However, if I run x equals x plus 2, just like I did before, x is now 5. And if I run it again, x is still 5. So what I've done here is assign x to the value of the previous value of x plus 2. So how Python evaluates this is x will get replaced with its value. So x will equal, and then it'll replace it with 3. And then you'll assign 3 plus 2 back into x. And now x will be equal to 5. Okay? So it turns out that if I happen to run this cell a couple of times, what do you think will happen to the value of x? X will now equal to 13. And that's because when I change the value of x here, what I'm doing is I'm saying take the previous value of x and add 2 to it. Okay? So even though x was 5 the first time I ran it, when I ran the previous cell a couple of times, I get a different value of x that comes out. This may seem obvious to you now, but I'll give you guys some problems later on that hopefully will illustrate this idea of mutation. So you want to be careful with this, because now the value of x depends on how many times you ran the previous cell, which can result in some problems. Any questions about what I've shown there? Yeah, Emily?
Can you undo, like, having run it the cell multiple times?
Yeah, so Emily asked, can I undo having run the cell multiple times? Unfortunately not. However, you can reset x back to this value, x equal to 3. And now I can run it just once, and now x is 5. So I can kind of reset that way. Another way of resetting is to go into kernel and restart. So if I do kernel restart, I wipe away all my variables and have to run every cell again. But I won't have the issue of having accidentally running this cell like 5 times. Any other questions? All right. So let me show you perhaps a more interesting example called Menard's map. Okay. So Charles Joseph Menard was a civil engineer in France. He created what many consider to be one of the greatest graphs of all time. So for those of you familiar with world history, Napoleon, the emperor of France, in his quest to conquer the world, tried to invade Russia in 1812. And the Russians, being the shrewd people that they are, said, OK, well, they're trying to invade during the winter. Let's just go hide out deep inside Russia and see if they survive the winter. Unfortunately, Napoleon did not survive the winter. And so Charles Menard made a visualization of Napoleon's march into Russia and then back out of Russia. He actually was able to illustrate a lot of different variables at the same time. And I'm going to show you what the map looks like. It looks like this. So what you can see here is that Napoleon's army started here. And you can see the way that they moved into Russia. And the width of the line here shows how many soldiers Napoleon's army contains. So you can see the army getting smaller and smaller and smaller and smaller. And then they get to Moscow and they realize that, oh crap, we're all dead, so let's go back. So they run back and they run back and they get smaller and smaller and smaller and smaller, and then soon there's like no one left. Okay, so it was a bad time for Napoleon. Okay. So what's interesting about this plot, or this graph, is that it shows many different variables at the same time, right? So you get not only the latitude and the longitude, you also get whether Napoleon was going into Russia or out of Russia. You also get the size of his army. And what Menard did was he took the temperature on Napoleon's return trip out of Moscow. So you can see here, the line here shows the temperature on the day that he started to leave. And then kind of partway through his journey, he showed temperature again. And then here is another temperature. So you can kind of see everything at once. So you get the big picture of Napoleon's march into and out of Russia, the unfortunate state of his army afterward, and the temperature that he was working through. So right here, I believe this is -50 degrees Fahrenheit, which is quite cold. Or -30 degrees Fahrenheit, sorry, which is quite cold. And that was when he was right here. OK? Cool. So we can take a look at the data present in this visualization with the table. So what we can do here is take the data points in this plot. We can take the longitude and the latitude of different places, different points in time, the city that Napoleon was marching through, whether he was advancing or retreating, and a number of survivors. I wanted to point out in this slide that we have a couple of different types of columns. Okay, so this column here contains all floats. This column here contains all strings. This column contains all integers. Each column needs to contain the same type, but the columns can contain different types. Like the column A does not have to contain the same type as column B. All right, so let's take a look at the data. So what I'm going to do now is take Menard, and what I'm going to do is I'm going to, instead of typing in the data manually, I'm going to read the table from an online place where we have stored the data, menard.csv. And if I do that, I should see this table. So now we have this table in Python. I did not have to type in every single one of these values individually, so it's highly convenient. Now what you'll see here is I use table.readTable, and I made it look, I said go to this website and grab this CSV file. The CSV file is a file, it stands for comma separated values. And if I download that file, hide that, open that, you'll see that it shows the data in kind of a tabular format where every column is separated by a comma. Okay, so hence comma separated values file. Now it's not super readable here, but this format is pretty convenient for Python to read, which is why Python can read it. Any questions? Cool, let's move on. But here's a table. Let's start working with it. So tables have a number of convenient attributes. So if I ask for the num columns, I can get 5. If I ask for the number of rows, I get 8. Sorry, num rows. OK, so the table has 5 columns, 8 rows. And I can grab the labels of those columns with menard.labels. And if I want to relabel a column, so if I want to change the name of a column, I can call menard.relabeled city with city name. And when I do that, the city column is renamed to city name, which is more descriptive than before. This is highly convenient when working with data that are not particularly well labeled. For example, we'll see next week when we work with census data, all the columns are named something like NC 1004, NC 1005. So being able to relabel columns is pretty convenient because it lets you keep track of what's in each column. Again, if I look at the Menard table, you'll see that the column city has not been renamed to city name. Okay, so again, relabel does not change the original table Menard. It creates a new table that has a column city name instead of city. So if I want to save that result, I actually have to do menard equals menard.relabeled. And now menard contains the city name column. Right? So lots of gotchas there, but just make sure that when you're trying to call a method and you want to save the result, you have to assign it back into the original variable or assign it into a new variable. OK. Now, let's say I decide to run this a second time. When I try to run this cell a second time, it breaks. Can anyone guess why it breaks the second time? Yeah, name and guess.
My name is Alien.
Alien.
My guess is that it's because the city label no longer exists.
That's right. So Alien says, you changed Menard last time you ran it to change the city to city name. Okay, so the column city does not exist anymore in the original table. It's called city name. So when I try to relabel it again, it'll complain that there's no column called city because I got rid of that column. Okay, so again, an example of how when you change variables, you can get some interesting results. So just be careful and be aware that you might, so if you change variables, you might get different results depending on how many times you run them. And the second time you run cells, they might break depending on what your variables contain now. Okay, so what I'm going to do is reset the value of Menard. So read table again. And I'm going to run this once. So again, the error message here is really long, but you scroll past all of this code here and go down to the bottom. Typically, this is where you want to look. This usually contains helpful information to help you figure out what your problem was. It said invalid labels. column label must already exist in tables in order to be replaced. So again, there's no label called city. Let's run that again. Now Menard is city name, and I'll be careful not to run it a second time. Okay, cool. So to grab a single column out of the Menard table, I can just do column survivors. And here is the array containing all of the integers in this column here. Another way of doing the same thing is to use the index of the column. So column survivors is 0, 1, 2, 3, the fourth column in this table. So again, we start from 0, and we count up, and this is column number 4. So column number 4 will also give me back the same thing. So almost any time you use a label for a column, you can also use the index. Oftentimes, it's more clear to you later on when you go back and look at your code that this is a survivors column. So if I come back a month later and look at this, I'm like, column 4, what's that? I have to go back and look. So typically, this is more descriptive. But if you want to save yourself some time, you can also use the index. If I want to grab a single value out of the Menard table, I can look at column 4. And since column 4 is an array, I can use the .item method to grab item number 0, which is the number 145,000. Cool. Now let's add a column. So arrange my notes. All right. So what I'm going to do now is take that value, which is the initial number of survivors in Napoleon's army. So he started out with 145,000, and you can see that his army got sadly reduced to 12,000 at the very end of his trip. Okay, so I'm going to take the number of soldiers that he started out with and call it initial. What I'm going to do now is add a column to Menard. So I want to add a column. I'm going to call it percent surviving. What I can do here is I can take the column survivors, and I can divide it by the initial variable, which will then give me a column containing the percent of soldiers surviving at that particular point in Napoleon's trip. Okay, so there's a couple of things going on here. First is I grabbed the value of the fourth column, first line, so that's 145,000, and then here I create a new column containing the values in the survivors column divided by initial. If you remember how array arithmetic works, when I take the values in this column, which is an array, and divide it by initial, which is a number, I get back a new array with all divisions happening to each element of the array. So here I have percent surviving at each point in time, and you can see here, unfortunately, at the end of his trip, only 8% of his soldiers survived. Okay. Cool. If I want to grab values out of, let's say I want to grab some columns out of the Menard table, there's a method called select, which will allow me to select out some columns of the original table to make a new table. So longitude and direction. The select method returns a new table containing the longitude method and a direction column in this case. Another way of using select is to use the index of the columns. Okay, so again, I can say longitude is the 0th column, and direction is 1, 2, 3, column number 3. So I can also abbreviate this with select 0, 3, and I get the same results. Okay. Now, when I use select, I can chain together some methods. So here, Menard.select creates a table. So I can call select again on that table and just get back that single column. Okay. So now think about why this doesn't work. So this errors out, Menard.select 0, 3. I'm going to clear that. Clear that output. So that errors out. But I will argue that this does not error out. Talk with your neighbor about why the first one errors, but the second one doesn't. Okay, any volunteers? Yeah, Kevin?
Because there is no index column number 3, so we only have 2 columns, that's index 0 and 1. So that's why the first one is an index error.
That's right. So the first one, you get an index error if I ran it. So index error means that I'm trying to use an index number of a column that the table doesn't have. Okay. So just to remind you, when I do menard.select 0, 3, this table only has 2 columns. Okay. So when Python runs this, it runs this first, and then says, OK, this is now a table with 2 columns. When I call select on a table with 2 columns and try to grab column number 3, that's an error because there's only columns 0 and 1 in a 2-column table. That's why the first one errors out, but the second one does not error. And when I do that, I get direction. Okay. However, on the other hand, so let's go back to here. If I had replaced the indices with the name of the column, the labels of the column, so let's say I used longitude and direction. If I also write direction here, this will now work, right? Because after I ran the first select, the table still has a longitude and direction columns, so I can still select out the direction column. Okay? So when you're using indices, you have to be pretty careful about the number of columns your table has as you go through some different steps. If you use labels, you get the advantage that it's a little bit easier to keep track of. Okay? But you do have to type more. Cool. So now, let me ask you, let me see if I can grab the survivors column. So again, this is the column here containing the number of survivors, so grabbing that column. And let's see if I can add 1 to all values of that column. I get an error. Okay, so let me clear that. But when let's look clear. But when I take out the column survivors, Python is totally OK with that. Talk with your neighbor about why the first one errors there, but the second one does not. All right, any volunteers? Anyone have a guess? Why the first one error, second one does not? Yes, person next to Kevin, name and opinion. Luke, right.
I see the first one return a table, but not an array. So table does not support this operation. But the second one, it returns an array, and array can plus 1.
That's right. So Luke says, when I ran menard.select, I got a table. When I ran menard.column, I got an array. I can't add 1 to a table, but I can add 1 to an array. Right? So when I ran that, the error here was actually, so if you were paying attention and you caught the error quickly before I erased it, it says unsupported operand types for plus, table and int. Okay? So again, this is an example of how you have to be careful with the type of thing you're working with. Okay, so now we've gone over a bunch of different types in Python. We have int, float, string. Now we have tables. We have arrays and tables. Arrays and tables cannot be used interchangeably because they represent different things. So here, the select method will always return a table. Okay, so this is a table with 1 column, but it's still a table. And because it's a table, I can't add 1 to it because it's the wrong type. On the other hand, if I do menard.column survivors, this gives me back a different type of thing. It gives me back an array. And with arrays, I can add 1 to it. Okay, so be careful when you're working with these methods. Be very clear which type of thing is being returned by which method, and your life will be a lot easier. Cool. Any questions about what I did there? Yeah, Luke. Yep, so Luke asked, can I use the index instead of the string survivors? I certainly can. So if I go up here, I count 0, 1, 2, 3, 4. I can still use survivors. and that'll work, except it'll error out when I do +1. But this will work just fine. Oh, can I use index and label at the same time? So you're saying take longitude and use it index number 4. It turns out that works as well. Okay, so most of the time they can be used interchangeably. Nice question. All right. Okay, so another thing I can do here, so one more method for you guys to remember. If I want to get rid of some columns in the original table, I can do .drop instead of .select. So instead of only grabbing out the columns from the original table, .drop will keep everything except the columns that I pass in. So longitude, latitude, direction. If I drop these columns from the original table, then I get a new table with only these 3. Okay, so convenient sometimes when you only want to get rid of one column, but not the rest. Again, the drop method, like the select method, does not change the original table. So if I look at Menard now, it still has 6 columns. Okay, so drop, select, all these things do not change the original. So just keep that in mind. OK, let's go back to our presentation. And let's go back to our puzzle of the day, which is about the birthdays. OK, so among all 72 responses to the JDA welcome survey, we have 4 questions here. Go ahead and discuss them with your neighbor. What do you guys think? OK, anyone have a guess for the first one? Anyone want to take a random guess? 2. You think 2 people have your birthday? Your name is? Alan. So when's your birthday, Alan? January 6th. Alan thinks 15th. So Alan thinks 2 other people have your birthday. OK, anyone think, how many days do you think have at least 2 people with a birthday? Any guesses? Sorry, did you say 5? What was your name? Gaurav says 5. OK, so Gaurav thinks 5 days have at least 2 people. Who thinks, is there a day with at least 4 people? Anyone think there was at least 1? Seems unlikely. OK, so what's the largest number of people that all have the same birthday? How many of those do you guys think there were? 3. So Henry says 3. Any other guesses? 3, yes. 2. All right. So let's see what the results are. So there are 72 responses to the survey, and 14 people have the same birthday. Not like on the same day, but 14 people share a birthday with someone else. Sorry if that question was unclear. So if you look here, there's a couple of January. So sorry, was it Alan who guessed? You had 2 other people. Sorry, you're all by yourself. But May 1st has 2, May 26th has 3, August has 2. So there were six days with at least 1 birthday. So was it Henry or Gaurav? It was Gaurav. You said 5, pretty close. So yes, 6 here. And the most number of people with the same birthday is 3. Okay, so nice, whoever guessed that. Cool. I do want to. So I've got some interesting responses to the last question of the welcome survey, which is there anything you want to say? So here are some responses. One person said, I'm excited to take part in this amazing course. I hope to have a great summer semester. Woohoo, me too. Someone wrote, I'm already starting to prefer Python to MATLAB, LOL, which is very nice. Someone wrote, a binary gender categorization is a perfect categorization. Please change a nonsensical text on the survey. Unfortunately, I cannot for political purposes. Homework 1 took me 2 hours. I'm not even sure my answer is T caret T. I'm sorry to hear that. But the homeworks are meant to challenge you, so I hope that you felt challenged at least. And someone wrote, one person responded this, how did you hear about this course? Sweet word of mouth. Why do you want to take this course? I'd like to gain some programming experience, and I heard this was the place to be. Anything else you want to share? Oh, Sam, I've got too much I want to share. I'll be seeing you in office hours. I'll be seeing you too. The story was not anonymous, so I know who wrote this. OK, so I kind of wanted to end out the first part of our class by talking about the growth mindset. So this is kind of just a random off-topic thing, but I think it's important when talking about learning. Has anyone heard about the growth mindset, growth versus fixed? Cool, so it's new for most of us. So the growth mindset is an interesting piece of education psychology research that has become very popular in the years that it has been released. It was originally researched by this professor named Carol Dweck, who is very unfortunately at Stanford, but her research is good, so I can't deny her that. So what she did was she took 2 classrooms, okay, so 2 math classrooms. I believe they were 3rd graders. And what she did was she gave the 2 classrooms the same set of increasingly difficult math problems. Okay, so 2 classrooms at about the same math level. She gave them both the same set of increasingly difficult math problems. And to one classroom, as the students worked on their problems, she said, great job, guys. You guys are so smart. Keep going. Okay? So that was classroom A. Classroom B, on the other hand, she went up to, and whenever they got problems right, she was like, oh, I saw how hard you guys worked on this problem. Keep up the hard work. Okay? So 2 classrooms, she tried to make everything the same except for her compliments to the students. And what she found out was that as the problems got harder and harder, and students weren't able to do them the first time, it was quite interesting because classroom A gave up almost immediately. Okay? So as soon as they got to a problem that they thought was more difficult or they couldn't get immediately, they were like, I can't do this. This is too hard for me. I give up. On the other hand, classroom B kept going, and they were like, oh, let me try it out. And they got a lot farther than classroom A, even though both started out at about the same math competency and had about the same math ability. Okay? And she sat down with those results, and she was like, well, what does that mean? And what she decided, or what she hypothesized, was that there's kind of like two ends of a spectrum. Okay? So there's what she called the fixed mindset spectrum. So the fixed mindset end is the belief that intelligence, your basic intelligence, is static or fixed. Okay? And when that happens, so in that case, what she tried to do with classroom A is try to get them to think that their intelligence is fixed by saying, you're so smart. Okay? So when she said, you're so smart, the students believe that, oh, I'm getting these problems right because of my natural smartness. When I get the problems wrong, it's because I'm not smart enough, and I will never be smart enough. So why bother trying? So what happens is when you have this sort of mindset, when you run into difficulty, that implies that you'll never succeed because you don't have the ability to do so. You don't have the genes to do so. Because of that, you don't have much reason to try because your intelligence is fixed. Okay? And another thing that she noticed in her research was that when you offer criticism to people in this sort of mindset, criticism is often deflected or just denied because that implies that you aren't good enough. Like, I'm not good enough for it. I'll never be good enough, so I shouldn't even listen to this. On the other hand, with classroom B, by complimenting the students on their hard work, what she was trying to say to the students was that, yeah, the problem might be hard now, but if you work at it or put in effort, you can learn how to do it as well. You can grow your intelligence. So you believe that your intelligence can be developed. And because of that, when you run into difficulty, instead of giving up, you think, oh, this problem is hard. I got this far with effort and hard work. I can go farther if I put in more effort and more hard work. Because of that, people in this mindset use criticism to improve and learn because their focus is on growth and not on appearing like they have the ability or innate characteristics to succeed. Okay, so I mentioned this because for me personally, I was, in my opinion, at least academically, I was in a pretty like fixed mindset for most of my life, and I thought myself just stuck, and I thought that I wasn't good enough, right? So you guys ever feel me on that? Like you do something and it's hard, so you're like, oh, like why bother trying? It's not worth my effort. You kind of feel these thoughts going in your head, like I don't want to embarrass myself. Like you think all these things, and then you just give up and you try to move on to something else. And I think for me, what I realized was it gets hard for everyone, right? So if you go through school, you go through life, eventually you're going to run, almost no matter how good your like natural gifts are or natural abilities are, you're going to run into trouble. And when trouble comes, it's your mindset or the way you approach that problem that will determine how you deal with it or how you go forward. And for me, I ran into so many walls before I finally sat down and I was like, okay, I'm just going to focus on improving and trying to learn and not thinking about how good I look in front of other people. And I found out later that I was kind of going from fixed to growth in terms of that vocabulary. But I think for me, it was really important for me to kind of make the decision for myself. So I share this with you because in this class, you'll probably find it to be very difficult at some points. That's the way most Berkeley classes are, unfortunately. But hopefully, if you approach it with the right mindset, you can grow and you can learn and you can keep going. Okay, so I would like to ask you, where do you think you are on the fixed/growth spectrum? So think that to yourself, and we're going to take a 5-minute break and continue on afterward. Okay, so go for it.